that 5-year band. I don't know. He's a soccer player.
I know you are.
Imagine how painful that was.
Okay, look up, please. Okay, don't write anything down yet. Well, yeah, just watch. Okay, big idea. Look up. Look up. Okay, big idea. Something you've been doing for a long, long time is you have been dealing with situations like this. This is a really simple example, so don't overthink it. That's what I'm doing. Hold on. Okay. Look up. Raise your hand if you know the value of x. Raise your hand if you know the value of x. 4 points for Josh. Those knew it was 4. 4 points is what Josh went like this. That's why it was called. So you can thank Josh for getting 4 points instead of 1.
Big job.
Okay. Listen. Okay, really, really simple ideas. When you are solving an equation, you're simply trying to find the equation that will make, you're trying to find the value of x that makes the equation true. So x equal 4 is the value which makes the equation true. So you got it? Simple, we've been doing it for years. Okay, look up here. So new word today. This is known as a differential equation. Fancy name for an equation which contains a derivative. Okay? There are lots of different types of differential equations. We study only one type in this class. We study what are known as separable differential equations. You don't have to know that name. You do have to recognize the name differential equation. They'll talk about that. It's extremely common in the FRQ section to have one question where they ask you to find a solution to the differential equation. And usually it's worth about, first of all, just reviewing. Did I tell you how many points you are going to have to earn to get about a 4 on the AP test? Okay, did I tell you how many points are possible on the AP test? No. What is it? 108. Perfect. 2 points for Derek. Listen, there are 108 points possible on the AP test. They are equally divided between the multiple choice and the free response. Okay? To get a 4 on the AP test, you have to earn approximately 60 of those points. Okay? This will go up and down by 1 or 2 points every year, but not very much. And I've also checked most of the local universities. Every year people ask, I look them up. I've not seen a university nearby that awards more credit for a 5 than a 4. So the maximum amount of college credit can be gained by earning a 4. You don't have to get a 5. You should try to do the best you can. So 5 is great, but you don't have to. The point I'm trying to make is you're not trying to get 108 points. You're trying to get more than 60 to get a 4. 5 is about 72. So not a huge step above that, just a little bit. And these are approximate, but pretty good. So, okay, look here. On the FRQ section, there's going to be almost certainly, like it's every year they've done this, without exception, there will be a question that says, they'll use different wording, but they'll be asking you to find the solution to a differential equation. Okay, that will be worth usually 6, 7, 8 points. Just that one problem. So it's a big one. It's important to make sure you're comfortable with it because it's a really good place to get a bunch of points. Here's the big idea. To find the solution to this equation, you simply find the value of x which makes the equation true. To find the solution to this equation, you simply find the formula, not a value. The formula, f of x, or if you like, you can call the formula y, it doesn't matter. You find the formula which makes this true. In other words, you're trying to find some formula like y equals x squared, so that when you take the derivative of that formula, you get this differential equation. That's essentially what you are trying to do. Okay? So this is not the correct solution, because when I take the derivative of this formula, I'm not getting this differential equation. But that's all we're doing when we solve a differential equation. Just like this. Find the value of x, which makes the equation true. Find the formula, which makes the equation true. So that's kind of a new step. I don't think you've ever done that in a math class prior to today, where you solved an equation and the solution was a formula, not a number. Questions? Awesome. Okay. There is a procedure, a step-by-step method for doing this. So here we go. Let's clear this off. To solve the differential equation, the first step is to separate the variables. You separate the variables by basically multiplying both sides of the equation, or dividing, until all of the x's are on the right and all the y's are on the left. Better said, all the input variables are on the right, all the output variables are on the left. You can look at this symbol here, dy dx, and identify that the output variable is always the variable on top, the input is always the variable on the bottom. So the first step in solving the differential equation never changes. You always multiply both sides by dx. So step one is always the same. Multiply both sides by dx. Again, we looked at the equation. We noticed that the output variable is y, input is x. So we want to separate those variables. All inputs on the right, all outputs on the left. Where the constants end up, we don't care. They just kind of end up wherever they end up naturally without really thinking about it. Questions? So now I'm going to multiply both sides by e to the 2y, and that will complete the separation of the variables. Questions? You typically earn 1 point for simply separating the variables. This is why most people are more comfortable with multiple choice, because there's a safety net. Like, you see the answers, you're like, oh, I can pick something. But in reality, people leaving this room always score a lot higher on the FRQ section. It's because of things like this. If you get this far, you've earned a point. If you can't go any further, you've earned almost as much as you can earn from an entire multiple choice question, simply by separating the variables. Cool. Next step, we anti-differentiate both sides of the equation. So we take this side of the equation, we apply the antiderivative operator. We take this side of the equation, we apply the antiderivative operator. This is the antiderivative in terms of y. So I look at my rule sheet and I'm like, oh, I have a rule. It's the expanded exponential rule. So a is 2 and b is 0. So I simply write down the antiderivative. 1 over a, e to the ax plus b. You don't have to write plus c. We're trying to find an equation that will make this equation true. The equation that we solve for will have a constant, but we can just kind of put that on at the end. But we don't have to do it along the way, we just add it at the end. So, cool. The right side over here, 3 is a multiplying constant. The antiderivative of x squared is x cubed over 3. And now we just remind ourselves that, yeah, we got to have a constant somewhere, so just throw one on. So, question?
We're going to simplify simplify the 3x cubed to over 3 to just x cubed?
Absolutely. So these will divide to make 1. So now we're here. So I have 1/2 e to the 2y equals x cubed plus an unknown constant. Please.
Will you remind me why we're not adding C on the left side?
On the left side. I think the best explanation would be this. Let's pretend. Let's do this. When we found this antiderivative, there would be some constant included. C is not special. It can be any letter. So I'm going to say plus A. On this side, I'm going to say plus B. And then what I do on the next step is I'm going to subtract the A to that side. So this would have been B minus A. And then I simply decide that rather than have two constants to worry about, because it doesn't really matter, I'm just going to say plus C. And the AP grader is fine if you just kind of do all that in your head. So you don't have to write plus A, you don't have to write plus B, you don't have to write plus B subtract A, you can just skip right to plus C. Does that answer your question? 2 points. Please, right.
So if you had like plus C on both sides, well, does that one work?
Yeah, that would give you a 0. There is a constant. We've got to not lose track of the fact that, and the constant could be 0. We just don't know yet. So that's why I don't worry about the A's and the B's or anything. I just put a plus C
You
here.
just know there has to be a constant.
A constant. Think of it this way. This might help. You know, maybe this constant was 12 and this one was 5. Well, you would have just put them together anyway. You wouldn't leave them separate. So we just say, let's just lump them together. Good? 2 points. No. Okay, cool. Next step. We've never done this before, so this is new. This part is not new. This is just antiderivatives. The separating a little bit new, but just simple algebra. The next step is new, but it's really intuitive. We have a way to find this value because they tell us right here that we're supposed to find an equation where if you plug in at x equals 0, you end up with a y value of 1/2. That's what this clue is telling you. Remember, solving a differential equation means find an equation. The equation is going to be y equals something or f equals something. But that equation is going to be written in such a way that if you plug in a 0 for x, you get a 1/2 for y. Knowing that allows me to solve for the constant. Because this equation has 1, 2, 3 unknowns, but I can plug in 2 of them. I can say when x is 0, y has to be 1/2. So I do that. Question. Now, one caution about the answers in the back. There are different ways to solve a differential equation. Both ways will give full credit. My method, I believe, is easier, quicker, faster, more reliable. You get more points following my method. But my method is slightly different than the answers in the back. So when it comes to finding the constant, you'll often notice that the constant I find may be a little different than the constant the answers show. Don't worry about it. Both methods are full credit. This way, in my opinion, is better. If you like the other way, you're free to use the other way. So, questions to hear? So 2 times 1/2 is 1. E to the 1 is e. So I have 1/2 times e is equal to the constant. So I found the constant. Question? No, good question. 2 points. When it says find the solution to a differential equation, remember where we started. We're trying to find an equation so that if we take the derivative of that equation, we get this. That's what we're trying to do. So far, we found a part of the equation because we now don't have an unknown constant. So what we do is go back to the green and plug it in. So now we know that 1/2 e to the 2y is equal to x cubed plus 1/2 e. Please.
Would that be the farthest you go, or do you have more steps here, or can we just leave it there?
Normally, if all that's left to do is add, subtract, multiply, and divide, you definitely can quit. If all that's left is algebraic rearrangement, simplification, you can quit. We haven't gone far enough yet because it says find a solution y, or f of x. So we have to end up with y equals something. And because we have not isolated the y, we've got to keep going. So I want to get the y alone. So I'm going to multiply both sides by 2. The 2 will have to distribute. So I'll end up with 2x cubed. When the 2 distributes here, I'll end up with plus e. 2 points for Parker. Questions? Okay, I'm going to copy this over so I can get some more space. I'll send you this just in case our board has trouble again. But yeah, there's a rule that you are supposed to have learned in a previous class that we need to use now. If you have totally forgotten the rule, or if you're like, I don't have any recollection of the rule, you don't need to worry. Just write it down and memorize it now, okay? The rule is really simple. I believe I've shown you this earlier this year. Natural log of e to any exponent is simply the exponent. Similarly, e raised to the natural log of some value is simply the value. Those rules are true because the e to an exponent and the natural log are inverse functions of each other. So that's why those 2 rules work. Questions? So we're trying to get y alone. So now all we're going to do is take the natural log of both sides. So I take the natural log, e raised to the 2y must equal the natural log 2x cubed plus e. Because of the rule, natural log of e raised to the 2y is simply 2y. Divide both sides by 2, collect my 7 points, go home. I have found an equation that if I take the derivative of this equation, I will get what I started with. Question?
Did you just,
Point. You know? Cool. you look in the back, I don't know if I copied over the answers. Yeah, I forgot to copy the answers. Hold on. If you look in the back of your packet, let me just copy those over real fast. Hold on. Notice how the scoring works. So 1 point for separating the variables. 1 point each for doing the two antiderivatives. Some problems will give you 1 point total. 1 point, so right here, it says 1 point for the constant of integration. That's finding C. 1 point for using the initial condition. That's where we plugged in 0 for x and 1/2 for y in order to find C. So basically the process of finding C was worth 2 points, and then the final point is for getting y alone. Please.
How often will, or how many of these questions will be on a test, would you guess?
Almost always just one.
Just one.
Well, actually, fairly common to have one in the FRQ section that will be worth 6 to 7 points, maybe 5 to 7. And then fairly common to have one in the multiple choice section, which isn't my favorite, because in the multiple choice section, it's only going to be worth 1.25 points to do the same work. Yeah, so I much prefer the FRQ one, but I don't think I've ever seen more than 2.
Wait, when you say 1 to 5, does that mean that not all problems are worth the same points in multiple choice?
No, I said that badly, sorry. On the multiple choice section, every single problem is worth this.
1 point.
1 1/4 points. Yeah. Gotcha, I see what you mean, like 1, 2, 5, yeah. No, every multiple choice is the same, so. 2 points for Matt and 2 for Ray. Question?
How many multiple choices do you have?
There's a total of 45. 30 without your calculator, 15 with. Although the 15 with your calculator usually have about 5 that don't need a calculator either. It's just where they put them, so I don't know.
So that's fairly quick.
It's weird. You get 60 minutes to work on the 30 multiple choice without your calculator. You get 45 minutes to work on the 15 with. It's just how it's formatted. You don't really worry about it. You just do what you do. You know. Keep reminding yourself the goal is not to do all of them.
Yeah.
The goal is to find 60 points. Yeah. Every year is different, but for many years, people have come back and reported that I've had kids come back and say, I think I got every single one of the calculator ones right. They're like, I don't think I missed any, like maybe 1 or 2. But then they'll feel like the non-calculator multiple choice is really hard. They're like, guys, I feel like I couldn't do half of them.
Because it's just trying to get started.
You know, they are what they are.
Yeah.
So I keep reminding everyone, you're not trying to get all the points. Most people are very surprised by their score in July. I've gotten emails every year from students like, I was hoping for a 3, I cannot believe I got a 5. It's really common, so. Okay.